your rooms, right? Anybody doing anything exciting before I start the notes? Just going in the corners. Good, that's it. All right, sounds like a good time. All right, can't wait to hear about it when we get back. Can't wait to hear about it. All right, here's where we are now to finish the unit. Here's where we are. I have shown you all these great techniques to find a side and an angle. We spent 11 days on it, finding sides and angles. But the one big problem I had, and I don't know if you have it at all, is this stuff only works when? Right triangles, right? It only works if I got a right triangle in front of me. And let's be honest here, probably less than 10% of the time you're gonna have a right triangle. So the last part of this unit is, all right, let's still find sides, let's still find angles, but what if the triangle's not a right triangle? Which is most of the time. How do I find these sides and angles? Before I show you the first technique for today and do the first example with you, you guys are going to start seeing some new notation. And I just want you to be aware of it before you see it in problem number 1 today. All year long, we have been calling this side, side AB. It can be called another way as well, and that's how we're going to refer to it today. I'm going to call it side lowercase c. Why? What angle is it across from? C. All right. I'm going to tell you, hey, side A, lowercase a, equals 12. That means the side across from angle A is 12. So you're going to start seeing that more than just calling that BC, AC, and AB. We're going to start referring to the lowercase letters. All right. All good? All right. Let's take a dive into the first problem. I don't need to read to you all this stuff before. Let's take a dive into the first problem. And yes, it is my favorite directions because it's not your favorite. And that would be solve this triangle. First thing, thanks, Olivia. First thing we notice right off the bat, this isn't a what? It's not a right triangle. So goodbye to all those methods we just spent 2 quizzes on. But it is asking us to solve. I think we can solve for one thing on there, can't we? Maybe not the sides, but I think you guys can find angle C. So why don't we start there? All right, let's find angle C. At least we can start somewhere. All right, when you have it, let me know. Angle C. Ooh, Ian, angle C? 30 degrees. Perfect. So I'll put my 30 degrees right up in here. All right, now we're kind of stuck as far as the sides go, because Pythag, sine, cosine, tangent doesn't work. It's not a right triangle. We're all clear on that. So let me introduce to you, there's going to be 2 different methods I'm going to show you. First method's today. Second method is Monday we get back from break. This first method is called the law of sines. The law of sines, because it's going to have the sign in it. Law of sines. Here we go. Actually, first I need a decision to be made from somebody. 1-6. Zeev, do you want to find side A or side C? You got it. So, all right, here we go. Let's find side C, kids. The law of sines is a proportion. It is a proportion. Ready? All right, what is in the law of sines? The first thing is, it is a side over the sine of the angle across from it. So Zeev wanted to find side C, so that's what I'm going to start out with, side C. That's my variable. I put it over the sine of the angle across from it. What angle is across from side C? I know it's angle C, but how many degrees is it? 30. I don't put 30. It's the law of sines. It's the sine of 30. So it's the side over the sine of the angle across. And now I do the same exact thing on the other side of the proportion. Give me a side and the sine of the angle across. Now, let's be smart about this, right? I don't want to introduce a new variable, so I don't want to pick side A. Pick something you already know, which would be 28. All right, side length 28 over what angle is across from it? 40. So I'm going to put not 40. It's the sine of 40. This is how the law of sines works. Side over the sine of the angle across. Side across from the sine of the angle across. And don't look at this all crazy like we've never seen proportions before. How do we solve them? Yeah, let's go. Act like you've been there, right? We're going to cross multiply. So we're going to have sine of 40 times side C equals 28 times the sine of 30. And don't overcomplicate it. How am I going to get side C by itself? What do I still have to do on both sides? Just like you did when we did SOHCAHTOA. How do we get side C by itself? Divide by sine of 40. Yeah, not 40, sine of 40. So take both sides, divide by sine 40. And we're rounding our answers to the final. Rounding our final answers to the nearest tenth. So when you have that, typed all in your calculator, rounded correctly. Side C, nearest tenth. What do you got there, Gianna? 21 point. I just didn't hear you, but I'm 21.8. Got it. Yep. All right, we're good. 21.8. Let me put that in my diagram. All right, everyone ready to find A now, side A. I don't know if I got anybody here that thinks they're clever. Hey, let's use Pythagorean theorem. What's the problem? Not a right triangle. Can't use it. Can't use it unless it's a right triangle. So I got to go back to, I have no option, law of sines. All right, so side A over, what are we putting this one over? Angle opposite. That's what I was thinking. Good job. Sine of 110. Excellent. All right, now you guys have a choice what to do in the next one, right? We could use our previous answer of 21.8 over sine of 30. But again, you got to know what I'm going to say here. You can't use 21.8. What do we got to use instead if you choose to use that side? The unrounded answer. Good job. You guys are on fire today. Awesome. So if you don't use the 21.8, use the unrounded answer. I'm not, why haven't I bothered teaching? You're just going ahead and doing everything yourself. I'm just going to use what I always use what's given. 28 over sine 40. Yep, everyone's divided by sine of 40. Good. Good job. All right, when you have that value, let me know. Take your time when you have that value. Oh, boy, here we go. Matt, when you have that value, let me know. Round it to the nearest 10. What's it say on your calculator? 40.9. Nearest 10.
40.9.
You good? Okay, yeah. 40.9. Whoa, 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 whoa. Before we move on, though, let me just give you a quick way to check, because I know you honors kids definitely want to know, have some confidence that you got this problem right. Anytime you're asked to solve a triangle, once everything is filled in, look at it. Look at it. Does it fit into a fact we have discussed this year? What fact am I talking about? Where's the biggest side always located, Zeev? Let's see, 40.9 across from 110, which is the biggest angle. Smallest side, 21.8 across from the smallest angle, 30. Yeah, so have some confidence that you got it right. Questions about using law of sines. One doesn't make you great. All right, let's keep going. Oh, got to set up your own diagram here. Sorry. Got to set up your own diagram. So set up triangle DAT here and we'll talk. Everyone see the new notation now. T equals 21. That's the side across from angle T. And then we're looking for side D, the side across from angle D. Okay, before we begin, does everyone have that triangle set up? Anyone? Everyone got that triangle set up? I'm going to keep doing that triangle. Everybody good? That triangle. Gabby, yeah. That triangle, good. I wait all year for this. Come on, this problem. That triangle, humor me a little. Yep, we're good. Josh, you picked it up right away. All right, good. Had better reaction third period. There we go. Some of you probably still have no idea. You'll figure it out over break. Just ask somebody later. All right, yep, that triangle's all set. So I'm looking for side D across from 27, but sine 27. All right, now be careful. The only side I have left is 21, but I'm not just going to throw sine of 105 because it's the last angle left. You have to use the sine across from the side we're using. You have to use the angle across from the side. T's blank. I am not going to introduce a new variable, but could somebody help me with my problem? How can I find angle T there? Amy, how can I find angle T?
You do 180 subtracted by 27 and 105.
There you go. You guys know how to find it. I can't use 105 because it's the last angle left. We find angle T and plug it in. And what do we have for that one? 48 degrees. All right, so under 21, I should have sine 48, everybody. Sine 48. Now we can cross them up. Yes, sure, go ahead. Oh, love these directions. I always see everyone asking each other, what's nearest integer mean, Mr. Carlino? What does that mean again? All right, it's whole number. All right, the integers are positive and negative whole numbers, but we don't have to worry about negative here. So nearest whole number. Steve, again. Sure, you relax. Relax. Go ahead. There you go. Yep. Good catch. 13. All I've done with you guys. Find a side, find a side. Can I use law of sines to find an angle? And the answer is yes, I can. All right, but before we do that, hold on. Before we find the angle, I want to go back. When we did sine, cosine, tangent, SOHCAHTOA, we just took the quiz on it yesterday. When we found an angle, so for instance, you guys did a problem and it said, all right, hey, the sine of angle A equals 12 over 13, and you guys wanted to find angle A. You didn't cross multiply. You didn't cross multiply. What special thing did we have to do at the end of every problem when we found a degree? What did we need to do? Hi, what did we need to do? Shift, right? We had to do the arc, cosine, arc, sine. That's exactly what we're going to have to do here. Anytime you find an angle, I don't care what we're using, SOHCAHTOA, or in this case, law of sines, anytime you find an angle, you're going to have to use the shift button. So keep that in mind as we keep working here. So go ahead, set it up. I don't know if they have anything clever here. It's just triangle ABC. We're finding angle B. All right. He's asking me to find an angle. I'm going to have to use the shift button at the end. But we're far from that point right now. So, all right, here we go. Law of sines. Let's see what it looks like. I think everyone's comfortable doing side C over sine of 112. 10 over sine of 112. We're all good. All right, now what goes in the next one? Well, what's the other side? I know. 7. What are you going to put on the bottom? What do we put on the bottom here? Thoughts? Give it a shot. Nothing. Okay, okay, here's it. You think I just want a B or an X? That's it. I got to put the sign with it. Yes, we've been putting the sign with the angle all along, so keep putting the sign with the angle. There we go. So that's what it's going to look like, sine B, or you can do sine X or whatever variable floats your boat. All right, let's start cross multiplying now. And then I'll stop you again. So we have 10 times the sine of B is equal to 7 times the sine of 112 degrees. We are not going to find angle B until I know what sine B is. Okay, we are not going to find angle B until you know what the sine of angle B is. So we need to get the 10 out of there by dividing it out. So you got to solve for sine B first. Ready? Sine B equals, I'll go to my calculator with you guys as well. And don't worry about, never worry about what it's doing from here to here, reducing it. This is where I want to see right here. 0.649. Now, some of you are like, that's such a small degree measure. That's not angle B. That is not angle B. It's the sine ratio for angle B. You guys are just used to seeing this number as a fraction. All right, you guys are used to seeing the ratio, right? 2 over 3, 12 over 13. But now they put it in decimal form. So I'm going to go 0.64902. I'm going to write it out. 86982. That's not my angle. And plus, I'm never going to give you a problem where the angle's less than a degree. Come on. No, we're not going to do that. This is what this, again, you're used to seeing this as a fraction. So now what do I do to get angle B? Now is the time. Oh, I know what the sine ratio is equal to. Let's ask the calculator. Let's ask the calculator what angle has a sine ratio with this decimal. So what do I need to do now in my calculator? That's my shift time, my shift button. So B equals, this will pop up, arc sine. And now instead of plugging in a ratio, like you guys did, plug in the decimal form. All right, now I plug in the decimal form. And again, this only is for when I need to find an angle. I do my shift button on the calculator. And what do we get in? It's asking for the nearest degree here. Nearest degree, 1, 2. Olivia, what do you got? 40, good work. Hey, common sense check too. 40 degrees. Better to not have two angles that go over 180 because you still got a third one to deal with, right? So make sure it makes sense, that angle that you found. All right, we good. All right, buckle up now. I'm ending today on the break on a big note here. We are going to do example 4 together. 5 we're going to save until we get back from break because I want to remind you guys how we do law of sines again after 9 days off. All right, so we are only going to do example 4 together. Ooh, baby, here we go. I filled in the diagram for you. Got a couple of angle of elevations of 35 and 21. What's the height? Where do we find the height of the mountain? And also, too, there's a misprint here. I'm not trying to really trick you guys. It should be round to the nearest foot. All right, I want the units to be the same. All right, I'm not trying to make this more difficult by switching the units. All right, so we're keeping the units the same, feet. All right, we ready to do this? Whoa! We got right triangles here, don't we? Maybe we can do a little SOHCAHTOA action. Well, all right. let's go here. Let's take this right triangle. Let's take that one. I see 35. The H is what side? That's the opposite side, right? Oh, but what's the problem? There's no other side. There's no other side. Okay, so that's gone. Huh. What if, oh, wait. The big right triangle. The big one here is a right triangle. So can I go from 21? The H is still opposite. Can I use the 507 as adjacent? No, it doesn't belong to that one. We're stuck again, aren't we? I don't have another side to use. So does everyone see, even though I have right triangles, I still can't use SOHCAHTOA like I did for the quiz. All right, I'm going to need your help here because I don't want to give this away. This is a challenge one here. What can I do here to get to H eventually? I know I have 507. What's up, Zeev? Got a thought?
Yeah.
All right, I'm ready to listen.
So, angle A, B, that angle is because it's the other one, angle 35. So, you get that angle, and then you can use the log sine, two angles in one side.
To find H?
No, find the big side, and then you use
Good job. Okay, here, let me just regroup here and summarize what Zeev is saying. Remember this triangle here? Remember this one, guys? What was our problem? We didn't have another side to use. We had the opposite side, but we didn't have another side to use. So what Zeev is saying is, all right, let's back up. Let's use this triangle right here and find this side. That would give us a second side we need in this right triangle. Everyone see our plan now. It's going to be 2 steps. There's no way we're finding H in 1 step. No way. We don't have enough information. So this is going to be a 2-step problem. We're going to find X using this triangle, and then we'll bounce back to the right triangle and find H. All right, so that's our plan. Beautiful. And I don't know if you heard what he said at the beginning, but I need more than 21 degrees, though. I need more angles. So find the rest of the angles right now in that triangle we're using. So you got 21 already. You know, 35 and the one adjacent to it are linear pairs, so they're supplementary. So I have 145 here. And then what's up top? 14, yep. So does everyone see how I can use law of sines, not sine, cosine, tangent, but law of sines on that one? And this is, and honestly, guys, this is the main reason why I'm doing this problem with you, not because it's an honors level problem, but I want to make sure you realize when you use law of sines, hey, all 4 values need to come from the same triangle. You cannot bounce back and forth from 2 different triangles. So what I'm about to write here has to come from this triangle I highlighted in red. You can't all of a sudden use 35 degrees. You can't all of a sudden use H. All 4 values must come from the same triangle. So let's start with 507. What are we going to put 507 over? 507 over, Gianna, go ahead. Good. Notice she's using angle from the same triangle 507's in. And then now we want to find X, but be careful here. What do I put it over? What's the angle across from X? One zip, Matt. 21, good. Hey, don't get fooled. Don't use 90. You're in the wrong triangle. You're using different triangles now. It's got to be the same triangle. So 21. All right, let's solve for X. Cross multiply. Divide by sine of 14 on both sides. Anybody, I don't know how well you know me so far, but what am I about to say? There we go. We're not done with the problem. Don't you dare round this value. that your calculator over here?
Yeah.
Oh, sorry. I didn't mean to take it. I was going to say I didn't see a number on the back. Sorry. Sorry, I don't have this one done. Deal with it. I know it's what, 700, 900 something?
751.
Yeah. Here you go. 507 times sine of 21. Yep. Divided by sine of 14. There we go. 751.038057. There's X. And now we're ready to find H. Now, make sure you are working in this right triangle only. You all right over there?
Yeah.
All right. And here's breaking news. Law of sines, any triangle. Law of sines can be used in any triangle, including a right one. All right. So some of you guys want to go ahead and use opposite hypotenuse and do sine like we did for the quiz. You can. Let me show you, though, how you can use law of sines, too. Ready? H over sine of 35. Everyone's with me on those two values. Equals my value here, which I'm too lazy to put in there. Yep, I teach honors. Over, now I use sine of 90 because it's across from the 90-degree angle in that triangle. So you can use law of sines on any triangle, including a right one. If you don't feel comfortable doing that, just do instead sine of 35 equals opposite over hypotenuse, if you want to do it that way. This Numworks calculator makes it look intimidating at the end. Huh? Ton of parentheses, reduces stuff. But all we care about is the decimal, right? And getting 431 feet in this case. All right. So we will save problem 5 for when we get back from break, so we remind ourselves what law of sines was. But you guys right here, let's get cracking. All right. The more you do, the less you have over break. All right, so get your textbook pages out. Let's get moving.